Yo, yo, yo! Welcome to the channel. Um, this is going beyond the expected episode 2, alright? But I'm not sure if what I'm going to talk about today is actually beyond the expected. Because from my point of view, what I'm going to talk about today should be expected from you, alright? And the topic I'm going to talk about today is the relationship between differentiation and integration. All right, which by now you should know. If you're year 11, year 12, yeah. If you're not, I don't know why you're watching this particular video, because you're intrigued by the name of the title. Very nice. If you are year 11 or year 12 maths B student, you should somehow heard of differentiation and integration and the relationship between each other, right? So we know that the differentiation is finding the rate of something. Alright, so if we are given a function y is equal to, let's say x squared plus 5, right? And if you are asked to write to find the derivative of this, the derivative of y, most of the people would just go y dash is equal to 2x plus 5. No plus. This is 2x, right? And this is the power rule, right? They're deriving the equation with the power rule, which makes sense, which, is easy, effective, and accurate. All right. But I am not so convinced that we should putting y dash here, because what you are actually doing, if you want to, have a better understanding or have a deeper understanding of calculus, right? In general, calculus, differentiation, integration, they're both calculus. You should actually write this. Instead of y dash, we should write dy dx equals to 2x. And you will see this expression a lot in the textbook, right? Now, what this expression means is actually delta y, change, delta, d is equal to delta, which we can also express with a symbol this. Yeah, do you see the triangle symbol every now and then? That's just the delta. That also means the change of something, right? So in this case, delta y, it means the change of y divided by the change of x, right? And in mathematical terms, that would be the change of y with respect to the change of x. And that is what really differentiation is, right? Not just y dash, right? It's the change of y with respect to the change of x, right? Because in this case, we're having y and x, right? We're having y and x. But what happens if I change them? What happens if it's t and p? Would you still write y dash? No, right? You write t dash, right? If you're smart enough, you will write t dash instead. But what you actually should be writing, or I hope you should be doing this, it should be delta t over delta p, right? So we are differentiating t, right, or delta, differentiating t with respect to p. So the change of t with respect to the change of p. And that is what differentiation actually is, right? We're looking at the changes with respect to the two variables, right? So that's equal to 2p. So hopefully this stick into your head, and that's how you should be understanding differentiation, not merely writing down something dash or something dash, because that doesn't mean anything. Yeah, I know you can do that. It's not a wrong practice, but doing that is for those people who actually understand the concept of differentiation, and then they just want to write the things easier and or get lazy. But deep down, those people understand, whoever invented that expression actually understand what differentiation means before they actually take the easier, the lazier way to write out things. But deep down, they understand what it means. But right now, so many students actually don't know what that means, but they just write down y dash, or whatever. And the sad thing is, the big problem with that is when it came out in the exam, you know, student gets struck. It's like the student got struck by lightning. It's like, what is that? I've never seen that before. What is dt over dp or dy over dx? Or what does that mean? You know, if the question sometimes says the rate of change of something, you know, and they got stuck there and they don't know they don't know what it means, right? So you should have a better understanding of what differentiation is, you know, realizing what it is, and if you do that, you can understand integration a bit more, right? By that, what I mean is, if we do that, if I tell you, most of the time when you come across integration, right, you just get thrown by a question. Yeah, here, 2x, and then find the integral of this, and then most people will just go, oh, okay, is this 2x squared over 2, and the 2 cancel, is this x squared and plus c. And normally, you know, that is right. I'm not saying that is wrong. I'm not saying it is wrong. But do you know what is actually happening? You're just doing it because you've been told that this is the way to do it, right? So, and it doesn't, and just merely doing it doesn't really develop a connection between. Now, for the student, develop a connection between integration and differentiation. Right? The student are just treating, most of the time, the student are just treating them differently. You know, they're not the same thing. They're not related. We're just doing different questions, different problems, and different topics, which is ridiculous. Right? No. So Isaac Newton would be crying if that's what you think differentiation and integration is. Okay? They're related, guys. They're related. So if I give you a function, right? Y is equal to, you know, 2x squared plus 5x plus 4. Right? This is a quadratic now. And I'm asking you to find the derivative of this. All right. We go dy over dx, right? The change of y with respect to the change of x, or deriving the derivative of y with respect to x, derivative of x. Oh no, deriving y with respect to x. Okay, so we get 4x plus 5, right? And then, if you think about it logically, now this is just dy over dx, right? So that means we can actually move things around to make it go back to normal, you know? So if we actually make the put the dx over to this side, we get this expression. Right? And some people will say, okay, I've never seen that before. But look, you might not, this might look strange to you, but what happens if I do this? If I cover this up and put an integral sign here. Now, isn't that is what sort of things that you've been doing? Isn't this the thing that you've been doing? Right? Integrating 4x plus 5. Right? So, and what this actually means, this dx actually means is, just like derivative, we are deriving y with respect to x. So in this case, we are integrating the integral sign. We're integrating 4x plus 5 with respect to x. Yeah, so we're integrating the x's. All right. And what should be on the other side, you know, you should see it, you should have this in your mind. What should be on the other side would be dy. But it's not just dy, it's 1 multiplied by dy. Now this dot here, right? This dot here, it just means multiplied. All right, nothing else. It means multiply. All right. You know, most of the time people use the cross as multiply, but you know, mathematicians, they use dots as well. Dot also means multiplication. Okay. So since we've got the dy here, we are integrating 1 with respect to y. It's just like we're integrating 4x plus 5 with respect to x. All right, so there should be integral sign here. All right, so what happened? All right, when you just do the left hand side, what will happen? You're integrating a constant, or a number, with respect to a variable. What you get is easy. You get y, right? You're supposed to get y plus c, but we're gonna collect all the c's together and just put it on one side at the end. So let's just go y. Let's put it y right now. Oh no, let's keep it there. Just to let you see what actually happens. All right, y plus c, and we integrate here whatever we get. Right, we get 4x squared over 2 plus. Oh, this is the same as this scenario. We're integrating a constant or number with respect to the x, to a variable. We get this, right, plus c. All right, and then we combine the 2 plus c together because they're just constant. They're just some unknown constant. So this would become 2x squared plus 5x plus c. So that is the end. We'll get back to the original function, right? To the original function, 2x squared plus 5x plus 4. But in this case, our c is, we don't know. So that should be how you're understanding the relationship between differentiation and integration, right? And let me think. One more thing. All right. So, this is what I observe in most of the year 11 and year 12 students that I have tutored, right? If you are asked to differentiate this, right? You're differentiating. What are you doing? You're differentiating each of them separately, right? You do this one first, you plus, and then plus this one, and then plus this one, right? So you get 2x plus 4, and then supposed to be plus 0 right there, and we just don't write it. We just don't write it out, okay? So, because they are separated by addition or subtraction in this, in other cases, you can differentiate each of them individually with respect to x, okay? And that's what you do. Therefore, when you're integrating them, so let's just say integrate x squared plus 4x, plus 7. Integrate with respect to x, right? When you're integrating them, you can integrate them individually, right? So you can literally do this. Right, so you can actually distribute the integral sign into each of the numbers doing this, and then you get the same thing, right? You're integrating each of them individually, so this one's get x cubed over 3 plus, or this one becomes 2x squared, and this one just becomes 7x and plus c at the end, right? And a lot of people don't know this, believe it or not, right? A lot of people is not aware of this. So you can integrate them individually or distribute the integral sign into each of the numbers if the operation between them is addition or subtraction. Right? In multiplication, you can't. All right? But something that you can do in multiplication is this. Right? Something you can do in multiplication is this. Right? And the relationship between the 4 and the x is multiplication, right? So you can take this factor out. You can take this constant out here. It becomes this. And, all right? And it just becomes 2x squared. All right? Hopefully you guys should have you guys should know this. Hopefully. Right. What else? What else? I think some of the mistakes that people make. Couldn't think of any right now. But like I said, hopefully you should see what I meant, like the relation. Hopefully by watching this video, after watching this video, you should understand the relationship between differentiation and integration a bit more than before you watch this video. Okay, and if that happens, I have done my job. And the reason why this is important is because to differentiate, well, it's not about the differentiation. It's when you integrate, right? When you integrate some complicated bunch or some when you're doing some advanced integration, you will really need to understand the relationship between them. No, between differentiation and integration. So the reason why I'm doing this is hopefully for the B student, for the B student, if you want to move to the A rank, to the A level, you need to ask yourself, how well do you understand differentiation and integration? Right? Other than my video, you can always go on another YouTube channel, go into YouTube, go on to the internet to look for more. Right? Don't stop because your teacher has only taught you this. If you're really interested into it, and if you really want to achieve a good mark or achieve better than other people in your classes, you should do what they don't do. Right? If you want to achieve what other people's better than other people or more than other people, you will need to do more than the other people. Makes sense, right? If you do the same amount of work, or if you stop at where they stop, how could you expect yourself to, get better than them? Because, when we talk about personal difference, some people might be extremely gifted right at the beginning. And, without putting in other extra efforts, you might never be able to beat them. I'm not saying that you have to beat them or anything like that, but you get the point. So, yeah, hopefully after this particular video, you guys learn a bit more about the relationship between differentiation and integration, and hopefully it triggered that sense of curiosity inside you to look for more. All right? Because it triggered me when I first watched the YouTube, watch other mathematicians on YouTube how to do integration, and it just purely it just purely widened my horizon. All right, it's just I can see more, I can do more, and I want to learn more. It develops this positive feedback. So I hope this happens to you, to you who's watching this particular video as well. All right, and I guess this is the going beyond the expected bit of the video, right? Not the actual, the integration or differentiation method or anything like that, but is to have that hungriness or that urge to seek more. All right, don't be limited by, what happens at school. You can always do more in your leisure time. All right, you don't need a lot of time. Just 1 hour a day will do. Or even if that's too much, 30 minutes. Or even if that's too much, 15 minutes. Anything is better than nothing, right? Okay, I can blab on forever, but I'm gonna let you go now. Okay, so we'll see you next time.